Hello everybody, I'm back with yet another very simple but crucial demonstration. So this particular experiment that I'm going to demonstrate is very important in large-scale industries like petrochemical refineries and also in purification of solvents. So what is this experiment? This experiment is separation of miscible liquids by distillation. So what are miscible liquids? Miscible liquids are those liquids which, when mixed in any concentration or proportion, they form homogeneous mixture, that is, they form a single phase. If many liquids have formed a single phase or they form a homogeneous mixture, how do you separate them? So there is a simple procedure known as distillation. There are different kinds of distillation. That is simple distillation, which leads to many complex distillations. Today, what we are going to demonstrate is fractional distillation. For fractional distillation, the solvents that you choose or the homogeneous mixture that you have, each component should have a boiling point difference of at least 25 degrees Celsius difference between them. If not, if you don't have a 25 degree Celsius difference between them, it so happens that when you start heating the mixture, both the liquids starts boiling and they condense at the same time, and you will again collect a mixture. Today, the mixture or the homogeneous mixture that I am going to consider is mixture of water and ethanol. So water and ethanol will be taken in 1:1 ratio. So here I have 50 ml of water taken in the beaker, and this is ethanol around 50 ml in this beaker. So I'm going to mix both of them together and we are going to get a homogeneous mixture which just cannot be separated easily. So we are going to do with the help of fractional distillation. So I'm going to mix both of them. To begin with, the demonstration consists of apparatus like a conical flask which is of around 250 ml, a distillation head, and a thermometer is placed at the head of the distillate. And then this distillate is connected to a condenser. The condenser consists of two tubes wherein there is an inner tube through which the hot vapors enter from top and moves towards the bottom side, and there is an outer tube through which water enters from bottom upwards, and this particular water is being passed through these water pipes, which is in turn connected to a tap. The hot vapors passes through the inner tube. These hot vapors will be cooled by the water that is present in the outer tube, and then these hot vapors will be condensed and will be collected in the receiving flask. Let us now transfer the solvents with the help of a funnel. This is water. This is ethanol. Place the thermometer back. This is a heater, and then before we switch on the heater, make sure that you also put anti-bumping granules into this conical flask. I have used pebbles into the conical flask, and now I am going to start heating it. So I need to wait for some time. Now the temperature in the thermometer is 28 degrees Celsius. So when we start heating it, let's check at which temperature does the first solvent distills and condenses into the receiving flask. So now you see the solvent mixture inside the conical flask is getting heated up. They are boiling, and since ethanol has a lower boiling point, it vaporizes to the distill head, and now the temperature in the thermometer is around 80 degrees Celsius. So these vapors of ethanol will move towards the inner tube of the condenser. And you can also notice here that few ethanol drops have been collected here, but rest of the vapors passes through the condenser, and with the help of water circulation, these hot vapors gets cooled, they condense and will be collected into the conical flask. So now we have separated ethanol from water, and you all can see this in the conical flask. However, we can also test whether what we have collected is ethanol or not. Let's test this ethanol. And how do we test this? There are multiple ways to test the ethanol, but we'll do something interesting. This is an empty conical flask. So I'm going to add a bit of ethanol into this. Transfer a little bit and then just rotate your conical flask so that your ethanol gets dried up. So now you see the conical flask is dry. Wow, this was amazing. Can you all just comment on what happened? If you all know the answer, let me know in the comment section. To conclude, I have shown you the fractional distillation procedure, the distillation procedure which was used to separate ethanol from water. So this particular distillation process or other complex distillation process used in various applications and in large scale industries.
We are making these videos so that science learning can be fun and enjoyable. If you like our videos, please subscribe and don't forget to press on the bell icon so that you can keep getting the updates about our latest videos and experiments.